Welcome to Tech Teach.
So next we will see is selective repeat ARQ. So first of all, we will be looking at what is the limitation to the go back and ARQ. Whenever there is acknowledgement is not received, it has to send all the frames available into the of the current window, you can call it, is resend. Okay, so this is the limitation to the go back and ARQ. So to remove this disadvantage or this limitation of the go back and ARQ, there is a selective repeat ARQ. So one of the important point of selective repeat ARQ is it will be resending only those packets or those frames whose acknowledgement have not received. So this is the basic idea, because if we are sending again all the frames available into the window, that means we are again like congesting unnecessarily the channel basically. Okay, so to remove all these limitations of go back and ARQ, there is selective repeat ARQ. So it will be selectively sending the frames with a negative acknowledgement. So it is NACK. So negative acknowledgement in the sense, so those frames, the acknowledgement of those frames that have not been received, it will be receiving a negative acknowledgement, or the receiver. So suppose this is the sender and receiver. So here, whenever like suppose receiver have not received the frame number 2, in that case it will be sending a negative acknowledgement itself. Okay, so once it will be sending a negative acknowledgement, so negative acknowledgement is sent for the frame number 2. So frame number 2 will be only sent. It will not be sending all the frames that are available into the window. So this is the basic idea. Again, we consider here same frames. So again, there will be a window size. Suppose the window size is 4. Okay, so 4 will be sent. 4 frames will be sent at a time. 0, 1, 2, 3. And acknowledgement for the 0th is received. Then the frame number 4 will be sent. Then acknowledgement for the first one is received. Then frame number 5 will be sent. If the acknowledgement for the 2 is not received, okay, so if acknowledgement is not received, so once acknowledgement for 0 and 1 is received, so this is the frame. This window size will be like this one, then it will be like this is the window size. So now 2, 3, 4, 5 is there into the window. So when this is not received, so it will not be like, if 2 is not received, it's not like it will be sending every frames available into it. It will not be sending likewise. It will be sending the 2. If 2 is not received, if the timeout is there, so it will be sending 4, 5, and then once not received and the timeout is there. Suppose this is the point where timeout is there, then it will, what it will do is it will send 2. It will send the 2 again, and then this is the timeout. So suppose up to here, suppose the frame number 4 acknowledgement is received, okay, or the frame number 3 acknowledgement is received, then it will be sending the 6. Okay, so 6 it will be sending. Frame size will be like this. So this is how the selective repeat ARQ basically works. So it will be resending only the frame that is having the error. That is error in the sense that is lost in between. It will not be retransmitting all the frames that are available in all the frames that are available into the window. So here, whenever there is a packet that is not received, so basically it is like, suppose the 2 is not received by the receiver itself. If it is 2 is not received by the receiver, then the receiver will be sending a negative acknowledgement. Then it will be sending a negative acknowledgement. If negative acknowledgement is received, then the 2 will be sent again, or whatever the frame number is negatively acknowledged, then it will be resending only that frame. So this is the basic idea of selective repeat ARQ. So here, once the negative acknowledgement is received, then there is no role of like a sliding window. So once the negative acknowledgement is received, means that packet is not received, then it will be like one by one the packet will be keep on sending and receiving the acknowledgement. Okay, so this is the basic idea in selective repeat ARQ. One more thing is there, because after the negative acknowledgement, no rule of sliding window. if there is no role of sliding window in the sense like here order of the frames are not important here, because in go back and go back and ARQ at the receiver side we are having a sliding window that is having only one frame. Okay, so one frame sliding window was there, go back and ARQ. But in case of selective repeat ARQ, whatever is the size of the window at the sender side, same size of the window is there at the receiver side. So if suppose 2 is not acknowledged, or if 2 is not received, it is receiving the negative acknowledgement. In that case, the order of the frames have changed, because after 4, 5, then 2 is being sent, then 6 is sent, likewise. So the order of the frames are not important here in case of selective repeat ARQ, because at the receiver end also we are having a window that is having, like, suppose 4 is at the sender side, so 4 will be at here. So out of this 4, suppose 0, 1, 2, 3 we have seen here, 0, 1, 2, 3, in whatever order they are arriving at the receiver, that is not important. Once all the frames of the window is arrived, then only this complete window will be sent to the network layer. So this is the basic idea in case of selective repeat ARQ. So we will just go through some points later on. So here the format of send window is given for the selective repeat ARQ. In terms of window size, here the window size is 2 to the power m minus 1. So 2 to the power m minus 1, that means it is 2 to the power m divided by 2. That means it is half of 2 to the power m. Okay, so here the window size is being reduced. So why it is being reduced, we will just see what is the advantage of reducing the size of the window. Suppose if m is equals to 4, then 2 to the power 4 will be 16. So if 16 is there, so numbering of the frames will be starting from 0 to 15. So 0 to 15 will be the numbering, but the size of the window will be 16 divided by 2, that is 8. Okay, so only 8 frames will be there into the window, and the SF will be the one that is like this has been sent, but acknowledgement is being waiting for. Okay, so these are the red one is like the frames sent but not acknowledged, and these remaining 4 is like the frames that can be sent. So after receiving the acknowledgement from this red one, the next 4, 5, 6, 7 will be sent, and these are like already sent and acknowledged. These are like frames that cannot be sent because it is not available to the data link layer. So this is the basic idea about, yeah, the size of the frame will be 2 to the power m minus 1, 2 to the power m minus 1. But in case of go back and ARQ, the size was 2 to the power m minus 1. Okay, so in the receiver end, how the selective in the selective repeat ARQ, how the window will look like. So here at the receiver side, instead of having single frame window, it will be having the same size. So at the receiver side, our size, that is receiver size, window size is 2 to the power m minus 1, the same as the window size at the sender side. Here in that, suppose this is the window size. So this colored one is indicating like this has already been received and its acknowledgement have been sent, and white colored are basically the one whose frames are being waiting at the receiver end, and once the frames are received, they will be acknowledged. So this is like frames that can be received and stored for later delivery. So it will be stored. Okay, so these frames, whenever it is received or not, it will be stored. When all the frames are received and acknowledged, then these complete frames will be sent to the higher layer. This is the basic idea at the receiver side. So receiver side will be having the same number of window size. Yes, so here this is the design of the selective repeat ARQ. So in that, it is similar to that one, the previous one, but the only difference here is like instead of having like the size as only receiver side, here also at the sender side as well as the receiver side, the size will be same for the sliding window. Okay, so this is one thing. And also here order, because the size is higher at the receiver side, so the order is not important. So any order the packet can be received. So when all the packets are received at the receiver end, then the receiver will be sending to the higher layers. And also in terms of window size, so window size is 2 to the power m by 2, or we can call it like 2 to the power m minus 1. Then in the previous one, it was like higher, but here it is lower. So what is the role of the window size is given here again. So suppose the window size is 2 to the power m minus 1 and window size that is greater than 2 to the power m minus 1. So here m is equals to, suppose m is equals to 2 is there. So if m is equals to 2 is there, so 2 to the power 2 minus 1, that means 2 to the power 2 is this, window size is 2. And here m is equals to 2, then 2 to the power 2 minus 1, that is 2, and this is greater than 2 in the sense here the window size is considered to be 3. So what is the advantage and disadvantage? You can just look it here. So if the window size is 2, so what is the advantage in that case is, suppose window size is 2, then 0 and 1. So 0 frame is sent and acknowledgement is not received. So suppose it is a system where acknowledgement is not received at the receiver as the sender side. Then 0 and 1 is there, frame 0 is sent. It was waiting for 0 and 0 is received. So now the acknowledgement will be sent. Acknowledgement is sent, then the frame, the size of the window will be changing. So size of the window will be changing because it has sent the acknowledgement for 0. Next one is here acknowledgement is not received, so it is waiting for the acknowledgement. SF will be at 0. Then 1 is sent. 1 is the one that is sent. Frame number 1 is sent, and its acknowledgement is sent from this side. So once the acknowledgement is sent, it is going to the frame number 2. Okay, so now the receiver is waiting for frame number 2, but the sender, because window size is 2, so 2 times it will be waiting. One transmission time, then receiver time. When the timeout is there, when the timeout is there, because it has not received the acknowledgement, it will again send the 0 and then 1. Once it is sending the 0, here what is there is, if it is only the size is 2, then it is waiting for 2, but they are sending 0. That means it is correctly discarding it. Okay, so it is correctly discarding the packet. This is the case in case of if the window size is half. If suppose the window size is more than that, more than half, but less than the 2 to the power m, that means the window size is 3. In that case, what could be the disadvantage? Like similar is there. So after frame number 2, it will be, because it has received 2 and sent the acknowledgement, so it is waiting now for 3. Okay, when, and it is also waiting for 3, not only the 3, but inside this window it is having 301, and at that time it hasn't received any of the acknowledgement, so it will be again sending the 012. So it is when sending the frame number 0 again, because it has not received the acknowledgement, but this 0 will be interpreted as the 0th frame of the window 2. So this is the window 1 and this is window 2. Okay, so now because this is the window 2, okay, so 012 will be the window 2. So this frame that is sent is will be misunderstood by the receiver, like it is sending the 0th frame of the window 2, but actually it is sending the 0th frame of the first window. So this is how the basic idea is there. So that's why the in selective repeat ARQ, the window size is considered to be 2 to the power m minus 1, okay, half of the previous one. So in selective repeat ARQ, the size of the sender and receiver window must be at the most one half of the 2 to the power m, half of the 2 to the power m, and both are equal of size. So this is the algorithm that you can go through it, what for basic understanding. Okay, so here it is going to see like what is so it is at the receiver side, what is the window representation is there. So suppose before delivery in the sense before delivery of the frames, okay, before delivery of the frames to the network layer, this will be the window size. When suppose 2, 0, 1 and 2, so these are the frames whose acknowledgement have been received, and they have been, packet is means the frame is received and also acknowledgement is sent. So frame received and acknowledgement sent. If this is the case, it will be red. So once this is the case, then there will be sliding in the window. Sliding window will be likewise. So if the sliding window is there, so 0, 1, 2 will be sent to the network layer, and then After delivery, the next window size will be looking like this. Okay, this is the basic description of the sliding window in case of a receiver side is given. And here an example is given. You can just go through this example. That is about the basic working of the selective repeat ARQ.